What did we have last night? The radicals. This one, this one. All right, any questions about those? On number 12. Yes, I did. I want to talk about that one for just a second. Thank you for reminding me. Um, so number 12 was 3 times the square root of 578. And I told you you only had to memorize up through, 13 squared, which is 169. This one was actually 17 squared. 17 squared is, thank you, 289. And so 289 times 2 gives you the 578. So this would be the square root of 289 times the square root of 2, which would be, and remember this is multiplication here, times 17 times the square root of 2, which would be 34 root 2, and you can't forget that plus or minus that sits in the front. So if you struggled with that one, it was probably because you didn't go quite high enough on your perfect squares. Is that... What? It's 17 times 3. Oh. It's 17 times 3? Oh. I doubled it. I see what you're saying. I was like, no, it's not. I thought you were talking about under the radical. What's 17 times 3 then? 2, what? 50. There you go. Sorry. Thank y'all for telling me this time, though. Appreciate it. Any other questions? Simplifying radicals or on the back, the solving and simplifying? Which one? 9 on the back? Oh, that's a good one. This is 9 on the back. Negative 1/2 x squared plus 1 equals negative 39. So again, I'm moving in SAD map, right, to get x all by itself. So the first thing I want to do is to subtract 1 from, subtract 1 from both sides. I get negative 40. Yes. How do I get rid of that 1/2? Flip it, multiply by the flip. Aiden, I hope you got this because you're really into that phone. So I've got x squared equals positive 80, yes? Now what else? I got to do the square root and I got to simplify that 80. So what's the biggest perfect square I can divide 80 by? 16. 16 and what? 5. And the square root of 16 is, of course, 4. So I get plus or minus 4 root 5. Sure. Other questions? Anything at all? Pretty easy? Okay. Yeah. Yes. That's nice. And I didn't put it over 1. Somebody in third block yesterday said they were confused because I wasn't showing the 1 because 2 over 1 is just 2. But make sure if it's a fraction that's not 1/2, not the numerator's not 1, that you flip it, multiply by them. Both of them there. Anything else? Going kind of easy on you so far. All right. Well, let's start today then. Again, I'm not going to follow the notes as much on here as I will, well, follow them somewhat. But I do want to get through imaginary and complex today, and that way we're through. You'll have, tomorrow will be a group work. I'm not going to call it a project or a quiz. But what I'll do is within your group, you'll all work together. And whenever I take up something to grade like that, to save my grading time, since you're supposed to be working together anyway, I'll randomly select one from your group. That's the grade, and everybody in the group gets that grade to make sure everybody's working together in your group is what I'm getting at there. One group's work should not look exactly like another group's work because we're not working between groups. We're just in our one group, right? Does that make sense? Okay. All right, so that'll probably be tomorrow and then some more practice. That'll either be tomorrow or Thursday, one or the other. And then tomorrow will be, we may just finish this, have this do. This is a good bit. We'll see. Let's see how today goes and we'll see what we're going to do. All right, but I did want to talk about group work like that when I take it up to grade it. All right, let's talk about imaginary numbers. This is not an Algebra 1 topic, so this is totally new. Or I'm going to assume you've never seen imaginary numbers. This goes right along with what we did yesterday when we're solving with square roots, because we talked yesterday if it's not a perfect square, what we do and how we split it up. But what happens when I have a negative under the radical? Okay, so I'm solving this quadratic, and I get myself down as I solve to something like x squared equals -5. And I go, okay, well, I know I need to take the square root. And whenever I take the square root, I stop and I go, but wait. Can you do that? Why can you not do that? There are not two numbers that are exactly the same. You're exactly right. There are not two numbers that are exactly the same that are going to multiply to a negative value. Two negatives make a positive. Two positives make a positive. There's nothing to get me negative if they're both exactly the same. So what we do is we make imaginary numbers. So we let I, and this is just going to be a variable that always represents the same thing, kind of like pi always represents 3.14159, right? It goes on and on. I always represents the square root of -1. So if I think back to those properties I talked about yesterday, I could rewrite the square root of -5 as the square root of -1 times the square root of 5. Do you agree with that? And the square root of -1 is I still get the plus or minus in front. So pretty much I replace a negative under the radical with an I outside. If I had something and I'm solving and my solutions look like this, what does that tell me about the parabola? What do you think it tells me about the parabola? What do the solutions look like on the graph? What's special about that parabola? No solutions. There's no real solutions. We've been saying no solutions, but really there are solutions. Those solutions are just imaginary. So now we won't have no solution, we'll have no real solutions. Aren't y'all so excited? You thought you knew every kind of number there was? Y'all do not look excited. Okay, what if it is a perfect square? So what if I asked you to find the square root of -49? You absolutely are. You're still going to use the I, pull this out, right? So this is still I times the square root of 49, but now I know that the square root of 49 is what? 7. And so what I do is I do the plus or minus. When I have a whole number, I let the I follow that number. So if it's a radical, I put it in front of the radical. If it's a whole number, I put it after the number. Just like 2x, 3x, 4x, it would be 2i, 3i, 4i, and so on. So just recognize that form there is what I want you to see. Yes, ma'am. Because whenever you take a square root, so if I had the square root of 25, that could be 5 or -5, because -5 times -5 is positive 25 and positive 5. So it gives you two solutions every time is what it does. Other questions so far? Ooh, what if it's not a perfect square? Try this one. What do you think this would simplify down to? This is actually on your sheet. This is number 5 on the very front of your sheet. Try that one and see what happens. Got it? Still working? Don't know? What'd you do first? Tell me somebody that's got it. What'd you do first? Or what do you think you might do first? I pulled the I. I would pull the I out too. That'd be the first thing I'd do. I'd say, okay, well, I'm going to take this I out and make this square root of 32. Now what? Split 32. You're exactly right. How do you split it? Look at y'all. 16 and 2. Now what? Square root is 16. So that's 4. So remember the I comes before a radical but after a coefficient or a number. So I'm going to write this as 4I square root 2. And I am going to throw that plus or minus there in front. Make sense? It's not a whole lot in addition to what you were doing yesterday. The only difference is now if you see a negative under there, oh, I got to make it an I, right? So let's solve one and see what happens. Let's do number 9. Solve this one, try this one on your own, and then we'll come together and do it. Subtract 15. That's exactly what I would do also. So I have 4x squared equals -24. What now? Divide it by what? How did you know that you need to do this in this order? Yay, y'all. I haven't taught you anything else, you know, sad math. Okay, what's -24 divided by 4? -6. What do you do now? That's exactly right. I'm going to square root, take that I out. So plus or minus I times the square root of 6. How do you know you don't break it down again? Nothing goes into 6. There's not a perfect square you can divide 6 by, so I stop. Everybody okay? Y'all sure? Y'all got this so quick. I thought this was going to be, oh. Okay, let's talk about powers of I then. What I really want, well, we'll talk about powers of I, and then we'll talk about multiplying and dividing. For some reason, this trips students up every time we do it. Tell me what I equals. Not -1, but the square root of -1, right? So if I is the square root of -1, what do you think I squared would be? All right, let's think about this for just a second. If I have the square root of 3 and then I square it, what happens? You just get 3. These are opposite, right? They cancel each other out. So now what do you think I squared might be? The -1, that's right, -1. If I came here and I just squared this, it would just cancel out this radical and this exponent and leave me with just -1. How about I to the third? So now I take this I squared and I multiply it by I again. I hear positive ones. You might think differently. What would be -1 times I? Negative I. Somebody said it, I think. The negative square root of -1, or just negative I. So I to the third is the same thing as negative I. This gets real confusing. Stay with me because I'm going to keep going. What if I went to I to the fourth? So I'm going to square I squared. So what is I squared? What if I square that? Positive 1. You're exactly right. You know I'm going to go a little bit further because I'm extra. Moans and groans. How about I to the fifth? It would just be, well, look, so I'm at 1 and I'm multiplying by another I. Close. Not -1, but the square root of -1. It's the same thing as I. That's interesting. How about I to the sixth? Are you seeing the pattern? How about I to the seventh? I'm going to write it this way. Or negative I. How about I to the eighth? See what's happening here? How about I to the 15th power? So tell me what you're doing. Did you go through here and count and go 8, 9, 10, 11, 12, 13, 14, 15? Okay, so if you didn't do that, because, I mean, you're not wrong. But how might you be able to figure that out if you couldn't? Like, what if I gave you I to the 821? You're not going to count that many, right? How many? We call these iterations. What did you say? Divide? That's exactly what I would do. We call these iterations, okay? And it repeats after 4. So if I see how many times 4 will go into it. What is 821 divided by 4? It goes in evenly? Okay, so it goes in 205 whole times, right? And how many's left from that? So what is 4 times 205? No. Right? And I got one more left. Do you agree? So what would it be? If I've got one more iteration, I went all the way through them to here, and then I got one more left. See if it works. If I took 15, 4 goes into it how many times? 3 with how many left? 3. 1, 2, 3. Is that what you get? 4 goes into this 205 times with 1 left. So with 1 left, I'm back up at 1. So your remainder is the iteration that you use. Does that make sense? That's a big word that just means the number squared there. This would be the first iteration, the second, the third, and the fourth, and then they repeat. So your remainder is the one you look at. Does that make sense? Okay. Let's talk about some operations with imaginary numbers. Why can't they just... The complex is whenever it gets a little more difficult. All right. Do y'all need a little break? Y'all don't usually talk, and y'all... Okay, let's take a break about the iterations. And we just said that the answer is based on your remainder when you divide by 4. So if you get a remainder of 1, there's your answer. A remainder of 2, a remainder of 3, and if there's no remainder, it's just 1. Just so you know. Oh, we forgot the girls. All right, when I say operations, I'm talking about addition, subtraction, multiplication, and division. So let's talk about addition and subtraction first. This is super easy. This will be a little bit more difficult when we get to complex, but it's still really not that difficult. If I add or subtract imaginary numbers. Now remember, imaginary numbers are just a number with an I hooked to them, right? So maybe I have 3i minus 2i. Okay. Super duper easy. Think about this like combining like terms. That is all you do when you add or subtract imaginary numbers. So what is 3i minus 2i? It's just 1i. Y'all okay with that? Okay. I won't spend much longer than that. If you have things that are I times the square root of 2 plus I times the square root of 5, you can't combine those because the radicals aren't the same, so you just leave those written as is. Okay, and we'll talk about like radicals here real soon. But the only way I could combine them is if I had these radicals have to be the same in order to combine them. So then I would have 2i times the square root of 3. But you can't combine them unless those radicals are the same. So just be real careful there. But as far as whole number, just pure imaginary numbers like that, I just combine them just like I do like terms. Multiplication and division is going to follow the same type rules. Make sure you look for your I iterations. Iterations. What does that mean when I say look for iterations of I? Those exponents, right? So I to the third would simplify down to what? I to the second would simplify down to what? So when I talk about looking for iterations, that's what I'm talking about. But other than that, it's exactly the same. So let's do a couple examples. Let's actually do them off your sheet, so we'll do some of those together. Let's start easy. Let's start with number 15. 4i times 7. What do you think you do? If there was an x, what would you do? Add what? Well, this is multiply. No, that's okay. What would you do? Just multiply. What do you get? 28i squared, right? Because I times I is I squared, yes? So I get 28i squared, but remember, we're looking for those iterations of I, so this would become what? What's I squared? -1, so it's just -28. And in fact, anytime I squared is multiplied to a number, it just, it just changes the sign of the number. Let's do 17. It looks 17 is 2i to the third times 5i. What do you think happens here? What does 2i to the third mean? What does the exponent 3 tell me to do? Multiply it 3 times. That's exactly right. So that's really 2i times 2i times 2i times 5i. What would that give you? These 3 are 8. I've also got this 5 here. What's 8 times 5? 40 I to the fourth. That's exactly right. And now I stop and I go, but wait, I need to look for my iterations of I. I to the fourth is just 1. Do you agree? I to the fourth is 1. So this is really 40 times 1, which is 40. Does that make sense? Do you see what we're doing? Let's do one more before we do complex. Do 20. 20 brings back those properties of radicals. Oh, goodness, what should I do? Any ideas? There's more than one way to do this problem. Simplify, simplify what and how? Okay, so what do you want to do? Take what? Take all the i's out? Break 20. None of you are wrong. You could all do exactly what you're saying. There are 3 ways I could see this problem being done. Number 1, I could see you splitting up and simplifying, taking out an I from everything and simplifying each one. That's really 2 ways. And then the other way I could see you doing is if you put it all together under one radical, which is, this is the way I would be inclined to do it, but it's not wrong if you do it another way. And I would say -24 times -3 times -2, since they all sit, since I'm multiplying. But any way you do that, that would work. So this would be, if we want to split this up, we'll do it the way y'all said, since y'all didn't do it that way. We'll do it this way. Somebody said take the i's out. I times the square root of 3 times I times the square root of 2. which makes I to the what? Third, times the square root of 24, times the square root of 3, times the square root of 2. And then somebody said break 24 apart. 6 and 4. I've got I to the third. I've got 4. I've got 6, 3, and 2. Square root of 4 is 2, so now I have 2I cubed. Square root of 6, square root of 3, square root of 2. What should I do now? What is it? Anybody? What's I to the third? Okay, well, let's go ahead and change that. -1 square root of -1. Agreed? Times the square root of 6, square root of 3, square root of 2. You'll see when we get to the end of this that you could have done this a little bit easier, but I'm really doing this to show you that as long as you're following properties, you can go about it a long way or a short way, but you're going to still come back to the right answer. All right, so this is -2, and the square root of -1 is I, so I'm just going to put -2I. You see anything else I could do there? What? Doesn't what? Anybody? You don't see anything? What am I doing here? What's that property of radicals say? Can I put them under the same radical? Can I do this? You would think right. That's right. I can. That might be helpful. Let's see. -2I. What's 3 times 6 times 2? Ooh, was that helpful? What's the square root of 36? 6. That was very helpful. -2I times 6. -12I. That's exactly right. Treat that I like any other variable. All right, what you think? That's about as hard as the imaginary is going to get. The iterations of I is what's going to kill you there. All right. Skip over to the last page, the complex number page. I'm sorry it's so much today. I just know I'm not going to be here tomorrow and Thursday, so I want to make sure. I took it from y'all's last feedback, you would rather me do it in person than a recording. Does that work better? So I'll just kind of double up the lesson here a little bit instead of working through class so much, and we'll work through class tomorrow. All right, complex numbers. Complex numbers are made up of two parts. They're made up of a real number part. What's a real number? It could be a whole number. It could be, it's the numbers that you're used to working with, okay? And to that, I could either add or subtract an imaginary number. Any imaginary number in the whole world that I want, but together, when you add them together or put them together, since you can't combine them, they're not like terms, they together make up what we call a complex number. For example, 6 plus 2I is a complex number. 5 minus I is a complex number. 5I, however, is what kind of number? Imaginary, not complex. It's imaginary. It's an expression where you add or subtract the imaginary part, yes. And we are going to talk about the operations with complex numbers, and that's going to be it today. The addition, subtraction is easy, the multiplication is easy, the division is where it gets sticky. We didn't talk about division of imaginaries, but we're going to talk about that while we're here. It's the hardest. All right. When you add or subtract, again, you combine like terms. The only thing you have to be careful about here is if you're subtracting and you've got that parentheses that you're subtracting, that subtraction has to distribute through. So let me show you I'll work two examples with you before I get to multiplying. We'll just do 1 and 3. Those are good. Number 1 on your sheet. Negative 11 plus 3i plus 9 plus 2i. Do you agree that those are both complex numbers? What makes them complex? One real, one imaginary, added or subtracted together. So together they make a complex number. If I want to add these two complex numbers together, just look at the parts that go together. Look at the real number parts. Negative 11 and 9. What is negative 11 plus 9? What is it? Negative 2. And then look at the imaginary parts. What is 3i and 2i? That's it. Easy. What if I add a subtraction in? I still combine like terms. The difference here is I'm subtracting everything in this parenthesis, right? So I'm doing 7 minus 2, which is what? 5. And I'm doing negative 2i minus 6i. That's exactly right. Negative 8. That's the hardest part there, is understanding that you're subtracting everything in that parentheses that follows. Does that make sense? Do you need me to do another example, or are you okay? Another one? Okay. Let's do number 4. 6i minus 14 minus I plus 5 minus 3. If I'm working this, I'm probably working left to right and not doing more than 2 at a time, just to make sure that I keep everything in order here. So let's look at these two. That's right. So when we write complex numbers, we want to make sure we write the real number first, followed by the imaginary part. So here, 14 is the only real number. Do you see that? But it's not going to be positive 14. It's going to be negative, right? So I got negative 14. And how about the imaginary parts? What do you think you get? What is it? 7i. Positive 7i. Because I do 6i minus negative I. Is everybody good on that? Now I still have this plus 5 minus 3i over here on the end. So again, with the like terms, look at your real numbers first. What's negative 14 and 5? negative 9, and what's 7i and negative 3i? Go with me? Make sense? Sure? Everybody okay? All right, let's multiply. This is just distributing, but I have to make sure I look for my iterations when I'm done. Same process, the FOIL, the distribute, however you learned it, same thing. Just remember I times I is I squared, and I squared is the same thing as what? Negative 1. That's exactly right. Let's look at number 7. I have 7 plus I times 4 minus I. That 7 has to go to everything in the second parenthesis. So what is 7 times 4? Yep. 7 times negative I. 4i. I times negative I. Negative I squared. Now, do what? Do you remember? Good. I squared is the same thing as what? Negative 1. I'm going to put this imaginary 1 in front of here because we know every variable has a coefficient of 1, right? I want you to see that whatever this is, when the I squared is hooked to it, all it does is change the sign of the number and go away. So this becomes a positive 1. If that had been negative 8i squared, it would become positive 8. If it had been 4i squared, it would become negative 4. Whatever it is, the coefficient stays and changes the sign. That's it. That's all I squared does. Now combine like terms. I want the real numbers first. So what do I have? 28 and 1, which gives me what? Negative 7i and 4i? This one's not on your sheet, but do this. Multiply that out and see what you get. You might get anything funny? You just got a number? That's odd. 2 times 2 is 2 times negative 3i positive 6i minus 3i squared. This becomes what? Positive 3, right? Drop the I squared, change the sign of the number. Because I squared is what? You're just squaring I. You're not. Oh, you're right. I'm sorry. I didn't mean to scare you. I'm sorry. I scared you because I screamed, or I scared you because I did it wrong? Oh, okay. I never seen that. I make a lot of mistakes up here. It's okay. Do it on purpose to try to get you to catch my. No, I really don't. I really just make mistakes. Okay. And some of you said that cancels, and you're absolutely right. So I have 9 and 4. There's 13. That's right. You're absolutely right. What a great conjecture. That is correct. These are what we call complex conjugates. And that is a really, really fancy way to say that it's the same complex number with the middle sign changed. The only sign that changes is the middle. And when you multiply complex conjugates together, you end up with a real number. That's important to remember. Gosh, I really feel like I've thrown too much on you today that I need to stop, but I need to tell you this one more thing. Are y'all's brains about to explode? 4 and 9. Yeah, that's it. That's it. That's it. Okay, if smoke starts coming out of your ears, tell me, but I'm going to show you this one last thing. Sorry. Just because I know I'm not going to be here. We've done addition, we've done subtraction, we've done multiplication, but we have not done division of either imaginary or complex. So here's what I'm going to tell you. There are 2 scenarios. If you divide by an imaginary number versus a complex number, why might there be an issue dividing by either one of those? Think about it. Why could I not have 1 over 2i? What's wrong with that? It's not, but what else? Think about our properties of radicals we talked about. I is really what? I squares the square root of -1, and I can't have a square root in the bottom, right? So that's the problem. So I have to get rid of it. If I divide by, if I have a radical in the bottom, how do you get rid of it? Multiply by that radical top and bottom, right? So if I'm dividing by an imaginary number, all I'm going to do is multiply the top and bottom by I. That's it. Because that's my radical. That's where my problem is coming. But if I'm dividing by a complex, that's it for that one. How can I get the I to go away if I'm talking about a complex number? We just did it. You do the complex conjugate. I won't work through these with you, but I will just show you an example on here of what you'll need to multiply by. If you look on the very, very back of your sheet, 13, 14, 15, and 16 are all divided. It's okay to have an I up top. It's just not okay to have it in the bottom. 13, 14, 15, and 16 are all dividing by imaginaries. So for every one of those, all I'm doing is multiplying by an I on the top and the bottom. If I have I said I wasn't going to do it, but I need you to show you. If I have that, that's dividing by an imaginary, right? Even though it's a complex up top, I got an imaginary at the bottom. I'm just going to come here and say times I and times I. This becomes -4, right? Because 4i squared just changes the sign of the number. This one you will distribute through and simplify. Different than if I have this, because now that's a complex in the bottom. Do you see the difference? Can everybody see the difference here? This is number 15, and this is an imaginary number on the bottom. This is number 17, and in the bottom here is a complex. So you're looking to see, is it imaginary or is it complex? If it's imaginary, I top and bottom. If it's complex, what's the complex conjugate of 5 minus I? Yep. And you will distribute that and simplify it and clean it up. I know I went really fast. I know you're probably going to have questions about the imaginary and the complex, but I'm starting to see the smoke out of your ears right now.